Ravenous fires, searing heat waves, freakish storms. The summer of 2026 has already shattered meteorological records across several countries spanning the European continent. Europe, it is a continent which has weathered or survived centuries of deadly conflicts, centuries of ruinous wars and deadly epidemics, but has still survived. But that same European continent is now bearing the brunt of inclement and erratic, unforeseen climate and weather conditions, which is slowly and gradually bringing it to the brink of collapse. Put things into perspective, let us see or study some stats. 172,000 hectares of land already bearing the brunt, burnt under in Spain. 10,000, which is an underestimate, people across Spain and France have lost their lives. 300,000 people across Spain and France have been displaced. Europe bears an annual expenditure of 2.5 billion euros annually to cater to the needs of the loss of property, livelihood, to cater to those people who have been displaced, lost their lands. Europe is also the fastest warming continent across the planet. It is believed to be warming at a rate of about 2 times greater than rest of the continents. Then Bordeaux. Bordeaux is a city in France, here shown in the satellite image. Bordeaux. It had never experienced a day maximum temperature greater than 39 degrees Celsius from 1921 to 2000. But in this summer itself, it has experienced 8 days of temperature above this. Temperatures never ever experienced before, 44 degrees Celsius in France. Then France had experienced only 53 heat waves since 1947. Out of that, 28 heat waves France has experienced in the last 15 years itself. So you can see the extent of pandemonium, extent of the chaos. These are satellite images of the wildfires, which have been taking place recently in the summer, which is in Europe. Now, if I take you here, so the region that we are going to study is basically this. So here you can see Spain. I showed you Bordeaux, Barcelona, Valencia, Seville, Lisbon. Okay. So these areas. So recently, this Greece. Earlier also it has been affected by wildfires and massive high temperatures. This Italy, this is the Mediterranean Sea. So this we'll discuss. It is very interesting. So we'll discuss not only what and how the wildfires are affecting or causing chaos throughout Europe, but also how they are getting worse with time. Okay, so this is the region, this North Africa, some regions, Morocco. So mainly these, the developed regions we are going to study about. So first of all, definition. What exactly is a wildfire? So there are two words, wild and fire. So fire, wild. A rapid and uncontrollable fire which burns through vegetation associated with grasslands, forests, shrublands, bushes, peatlands. Okay, and is self-sustaining in nature. So it is rapid and uncontrollable. Fine. We'll stay to the point. So this, what you can see, is the fire triangle. So, three essential elements are needed to initiate and sustain the wildfire. One is fuel, in this case, the dried twigs, bushes, logs, branches, the undergrowth, vines, trees, canopies, leaves. Okay, then we need an initiator, heat. High temperature is already there, but we need a spark. And you will be surprised to know that all over the world, 90% of the wildfires are anthropogenic or caused by humans. Why? Because of negligence. In India, a simple bidi or cigarette, which is unextinguished before getting discarded. Then it can be campfire. It can be sometimes what happens is farmers, in order to clear land and replenish the soil with nutrients, they engaged in control burning. But that fire, if untended or uncatered to, that can also spread. It can become uncontrolled and spread rapidly. Okay, so all of this. Then, for example, in India, I'll give you a very good example. In the state of Odisha and Chhattisgarh, there is a species Maduka indica, which is mahua. So the tribes there, they gather the minor forest produce, the mahua flowers or the betel leaves. Those are made for, those are used for making pan leaves. Okay, and other such minor forest produce. So they have to clear the forest. So they produce or generate fires. Then shifting cultivation, the jhum cultivation in the northeastern parts of India. And the remaining 10% that is caused due to sparks, due to lightning, sparks due to the friction between railway lines and tracks. That is also an initiator. Then volcanic eruptions can also cause. Okay, so these are the natural causes, but 90% they are caused by negligence or anthropogenic human factors. Then oxygen, obviously we know 21% of the atmosphere it comprises of oxygen, and oxygen is necessary for combustion. So this, when these three are present, then a wildfire, a fire can be created, and when it turns catastrophic, when it starts consuming or devouring lives, biodiversity, homes, settlements, then it becomes a wildfire. Then these three, these correspond to the fire behavior triangle. Okay, now the wildfire has already been lit. Now what sustains, what are the factors that are responsible for sustaining and propagating it further? So one is the fuel. Fuel is the essential source. So we know that leaves, twigs, grass, bushes, vines, logs, pine cones, they are all flammable in nature and they can be easily used as fuel. Then weather. How weather? If the weather, the humidity is low, moisture is less, drought like conditions, dry weather, windy conditions. What does wind do? Okay, don't treat it like a candle. Wildfire is not equal to similar to a candle that we just blow and the candle gets extinguished. No. What wind does is strong windy conditions not only propagate or carry the flames further across the ground, it also replenishes the oxygen. Oxygen once consumed in one area, the wind then carries the combusted elements away and new oxygen is there to supply it. Then, so humidity, wind, these are the main weather factors. Okay, then topography. Topography, what is that? It is basically the study of the pattern or the differences in elevation, the shape of the land. So why it is important here? Especially when it comes to the hills. For example, what happens is if there is a tree here, so the fire somehow starts here on a tree which is at a lower elevation. So what happens is, because when a fire burns, the flame has a tendency to burn upwards. So this upwards burning or going flame, this preheats the vegetation and then it provides a stimulus or impetus for the upslope vegetation to catch fire. So the wildfire, which is once initiated at lower slopes or at lower elevations, it gets further propagated easily upslope. So this is also an important factor. Don't think that okay, high slopes there will be low temperatures. So no, temperature is not the main issue. We need fuel, heat, oxygen, and then this three factors to propagate or sustain it. That is why don't be surprised when you hear in the news that the Siberian region, which is very cold region, that is also highly susceptible to wildfire. The Amazon rainforest, which experiences heavy rainfall due to high exploitation, urbanization, cutting of trees, monocropping, all these even have made the Amazon rainforest highly susceptible to wildfire. So these are the basics. Now we have understood wildfires. What makes, what is the topic? Why is Europe burning? So what makes Europe highly susceptible to wildfires? Let us study that. First, before that, so there are three types, additional information, it is interesting. Three basic types of wildfire. One is, this is the ground fire, this is the surface fire, and this is the crown fire. So as you can gather or gauge from the words, surface, the dense undergrowth, bushes, the twigs, the leaves, which are close to the ground, they start burning. But this is easier to control. Okay. When the fires, the flames, they climb up the trees and they start burning the crowns or the high canopies of the trees, then it is known as the crown fire. And these can spread rapidly under the influence of strong winds to the tune of 20 kilometers per hour. These are the deadliest wildfires. They are also known by different names in different countries. For example, in Australia, you might have heard this, the bushfires. Okay, but commonly they are known as wildfires. Then this is ground fire. This, what happens is, for example, I talked about the fires, uncontrolled fires. I gave an example of peatland. So organic matter, when it is present, so these fires, they sustain themselves, they are not very harmful, but they continue burning way into winters. For months and months they keep burning, they don't get extinguished easily, and that is why they are also known as zombie fires. Okay, so these are the basic types of wildfires. Now we were talking about Europe, so don't get confused or overwhelmed by seeing this diagram. Actually, this diagram shows the Köppen climate classification, which I had prepared myself for sharing with students, but we are just going to concentrate on Europe. Fine. So if I want to mark the approximate boundary of Europe. So you can see that here, if I mark the Caucasus Mountains, three countries of Armenia, Azerbaijan, and Georgia. Then we have the Caspian Sea, and here we have the Ural Mountains. So this is, okay, this. So this is approximately Europe. We're studying Europe. Now, what I want to concentrate, just ignore everything else, just concentrate here. So the purple part, basically if we divide Europe's climate, we have to know what are the basic types of Europe's climate in order to study how and what region is getting affected. Okay, so this purple region, you can see United Kingdom is there, Ireland, then Portugal, Spain, France, Germany, Norway. So these are influenced by the winds, westerlies, if you want to be precise, which bring precipitation all throughout the year. So this region has moist weather conditions. It has relatively mild or cool summers and precipitation almost throughout the year. For example, in United Kingdom, you might have heard that it is in London or England, it is better to always carry an umbrella because the weather is very unpredictable. Okay, so this is one type of climate. Then Here, if you see the interior part, like if we compare Delhi with Mumbai, Delhi experiences extreme types of climate or continental. That is, in winters, the temperature goes very low, and in summers, the temperature goes very high. Okay, so normally what you have to see is Europe is lying approximately between 35 degrees to 70-degree north latitude. So compared to tropical region like India's mainland extent is from 8 degrees 4 minutes north to the northernmost tip 37 degrees 6 minutes north. So it experiences a relatively tropical or warm climate. But here the winters are much more severe and they experience mild summers. So it is very surprising to note that such a relatively cold continent or region is experiencing such frequency or intensity of wildfires. So that is a contradiction. That is an irony which we are going to study. So this is experience, but here also rainfall is less, but temperatures are relatively low. Then here in the tundra region or here in the Arctic region, the Arctic climate very cold, very short cool summers and very cold winters. Now here, this red portion, this is the region which is of importance to us right now. Why? Because of peculiar climate, which we'll see. This you can see Mediterranean. You can easily remember without, even if you don't remember what peculiarity or features are characteristic to this type of climate, you can easily locate it. This Northern Africa, this is the Mediterranean Sea, which I showed you in the world map. So we'll study the characteristics in detail. Okay. First of all, so why Europe? Okay. First of all, Europe is very near to the Arctic, like I showed you. So you can see here that Europe is very near to the Arctic. Now, this Arctic region. So Arctic itself, you might have studied that Arctic is warming about 3 to 4 times more rapidly as compared to the other parts of the world. So what is happening is Arctic, and it is in close proximity to Europe. So what is happening? Arctic ice is melting due to greenhouse gases or global warming. So there is an effect known as albedo, you might have heard. Okay? Albedo, now back to school, albedo is the proportion of sunlight that a surface reflects and sends back to space. So ice, snow has the highest albedo out of all the other objects or substances like forests, water, sand, etc. So that is why it helps to keep that Arctic region colder. But now, since the ice is melting, so that ice is now getting replaced by dark surfaces. So the dark surface is responsible for absorbing more insolation or radiation from the sun instead of reflecting it back immediately. And due to the proximity or nearness of the European continent to Arctic, Arctic is warming and so is the European continent. Okay. Now, Mediterranean region. This image or icon will help you remember it. Mediterranean region, you might have heard, it is famous for citrus fruits, for figs, for olive trees. Okay. Now, Mediterranean has a characteristic that it is dry in summer, but it is receives rainfall in winters. Okay. It is due to shifting of pressure belts, but I'll not go deep into that. Just remember this: dry summer, rainfall, winter. And what was one of the weather conditions which we studied earlier, which was responsible for sustaining and propagating the wildfires? Dry weather, less humidity. So not only are the temperatures high in this Mediterranean region, but the weather is also dry. Normally, India, like we're experiencing right now, July, August, September, these 3 4 months are the months which experience majority of the rainfall, the southwest monsoon. But here in these Mediterranean areas, like this parts of Portugal, Spain, France, Italy, Greece, okay, so these experience dry summers. So this is one factor. Then the land sea differential. Now you can see here Mediterranean Sea. If I show you the map again, the Mediterranean Sea is very closed in nature. It is surrounded by landmass. If we see other oceans like Arabian Sea, Indian Ocean, it is very enclosed. So as the land gets warmer or the oceans get warmer, so these effects get compounded and serve as a feedback loop. Land gets warmer, ocean gets warmer, ocean gets warmer, land gets warmer, in layman terms. Now, how is it important? You might have heard of this term, specific heat. Okay. So if I ask you a question, whether land has a higher specific heat or water has a high specific heat. So the correct answer is water. What does that mean? That is that to raise the temperature of water, much higher quantity of heat is required as compared to land. Okay, so what this means is, what this refers to is that land, it warms and cools much faster as compared to water. In fact, whatever the warming, global warming is taking place, 80 to 90% of that warming is absorbed by the water. Okay. Also, one interesting fact which you might have come across literature, newspaper, or other textbooks is that for every 1 degree Celsius rise in temperature, the moisture holding capacity of the atmosphere or the air, it increases by 7%. Now, why did I mention this so-called random fact? It is because although the global warming is responsible for raising worldwide atmospheric temperatures, but it is also increasing or enhancing atmospheres or the air's capacity to hold water for a larger amount of time. So whenever rainfall or an event such as cloudburst takes place, so a lot of water that has been accumulated due to warm atmosphere, that is shed at in a very short period of time, and that can be devastating in nature. And this we will study as a very important novel term, climate whiplash. So even if the global warming is taking place, that does not automatically indicate that rainfall is decreasing. No, the extremes or the intensity of droughts, rainfalls, floods, all these have increased. So at a particular region, a lot of rainfall is taking place, another region it may suffer from drought, or the same region after a season of dry temperatures, it can experience a lot of rainfall. So this is an important pattern, the climate whiplash, the extremes of temperature or weather conditions or climatic conditions. Okay, then obviously we have the greenhouse gases like CO2, methane, which is increasing the temperatures. Okay, one more interesting fact now, or when I show you the image, so I hope this reason is clear why Europe is bearing. First of all, scientists have established that it is warming up to 2 times the rate of all the other continents. It is the fastest warming continent. Arctic is known as Arctic amplification. You warm, you melt the ice, the albedo reduces, then heat absorption takes place. Then the Mediterranean nature, okay, that is especially worsening the conditions in areas or territories, the southwest region of Europe, the southern region of Europe, like Greece, Spain, Italy, France, Portugal. Then land sea differential, carbon dioxide. Okay, I was talking about the globe. You might have observed that in India, although it is not much visible, the difference is not much visible, but you have observed that in the summer season, the days get longer. Okay, so what that means is that in the summer season, the length of day is greater than 12 hours, the length of night is less than 12 hours. This difference is even more enhanced or even more emphasized in the higher latitudes. Okay, why? For example, right now the earth is in this position. Okay, suppose we take this, the sunlight is coming from this, the northern hemisphere is tilted towards the sun. So even if, suppose, are in India, like I am in Delhi, so if I suppose I experience 14 hours of sunlight and 10 hours of night time, the higher latitudes like Europe, they experience extremes of day and night. That is, that can be up to the tune of, for example, 18 hours of daylight, 6 hours of. So even we know that the temperature is lower than the tropical areas like India. But during summers, it is receiving insolation or the sun's radiation for a longer period of time. So we know that even if the land is getting heated and cooled rapidly as compared to water, but it is getting heated for 18 hours, the time for cooling it is very less. So that is also becoming one of the factors behind the droughts, the dry weather, less humidity, and the sustaining of wildfires. Okay. Now, this portion is interesting, but for your own sake, you can skip this and go to the next chapter via the timestamps. But it is interesting. You should note that why this is becoming common. This is an unprecedented, unforeseen circumstance. Like I said, that Bordeaux had never experienced a temperature greater than 39 degrees Celsius till 2000. No such days of heat waves. Okay, so jet stream. So I have discussed in some of the previous lectures also. So what exactly is a jet stream in layman terms? Jet streams, they are the long, meandering, narrow bands of wind which blow in the upper troposphere near the tropopause. So we have winds normally. What is wind? It is the horizontal movement of air. So these winds, these blow in higher altitudes. Okay, in higher, much higher, in 9 to 16 kilometers above the Earth's surface. So they are blowing happily. Now, their property, main property which influences climate is that due to temperature differences, now here is the cold air mass, cold air, this is the hot air mass. So due to differences, they start meandering. Meandering means they start making waves. Okay, so the cold air mass is tries to enter here, warm air mass tries to go towards the north. Just layman, I'm not going to confuse you by discussing the intricacies. So sometimes what happens, and this has become particularly pronounced due to global warming, the Arctic amplification, the temperature contrast has been affected to such a level that this meandering has increased in recent times. So this is also known as this shape. When it takes, you can see the Greek letter omega. It resembles. So you might, so don't be afraid when you read this omega block as a reason for high temperatures in Europe or maybe in North America also. So what happens is, just remember here, this is treated as a ridge, this upward going, because it is three-dimensional. It is not only the jet stream is not only going north, it is also going up and down. Okay, the latitude is also varying. So this high pressure, when it takes an omega, the form or shape of omega, and it is surrounded by two low pressure cells, and it becomes stagnant for quite some time, it traps the weather conditions that exist there. So basically, omega block is not directly responsible for the heat wave. It is actually a pattern of atmospheric circulation which is responsible for sustaining and propagating heat wave conditions. Okay, now we'll So this is in the upper atmosphere. For example, is this the surface? I have created a high pressure condition in the sky. Now, what is actually happening? So here we know that the omega block is working, high pressure conditions are there. Now this is what leads to the formation of heat dome. Normally what happens is that when climate change was not as pronounced as is happening today, so these low pressure and high pressure ridges and troughs, they used to move along, wave along and move along from west to east along with the jet stream. So that is why we used to experience varied weather. Weather conditions didn't stay stagnant or the same for an extended period of time. But now what is happening is, either if this is, for example, if this is creating high temperatures at the surface, similarly this low pressure causes the rise of air and excessive precipitation. So this will incur, or this region will experience days of non-stop rainfall or cloudy weather. Okay, so this is the main thing. So now we are discussing heat dome. So what is happening in the Europe, why the heat wave or the heat conditions have exacerbated or they have worsened, is because heat, this pressure, what it is doing is it is sort of creating a lid. For example, if this we say that this is Spain and France, so this heat dome is not allowing the air to rise. See, it is only summers. Normally what happens, for rainfall to occur in any area, for example in India, monsoon, the land, the basic concept is land warms up, the warm air rises, it gets cooled, it gets condensed into water vapor, they form clouds, and when the gravity becomes too much, the clouds can no longer hold against the gravity, it forms as precipitation. Now here what is happening is, we have, the air is already dry. Moreover, this high pressure is sort of, in layman terms, it is compressing the air, it is not allowing the air to rise. So if the air will not rise, it will not condense and it will not form water vapor, it will not form clouds, and rainfall will not take place, it will not reduce temperature. Moreover, so this is one, okay, the compression. Moreover, you might have heard of this term, adiabatic heating. Okay, if we try to define it, adiabatic heating or adiabatic exchange of heat is a mechanism in which a particular parcel or packet of air, it warms or cools without exchanging heat from the surroundings. So this is the definition. In simple words, for example, what is happening? Consider this packet of air which is at 10 degrees Celsius. Okay, so when it descends, it is getting compressed. More and more air is everywhere, more and more air is getting piled upon it. So if we go to the basics, if I say that this air packet consists of small molecules, okay, same amount of molecules, for example 20 molecules are there. So in this packet, which has a larger volume, they are spaced wider apart. Okay, now it goes further down under the weight of compression. So what will happen when these molecules, they are compressed? These 20 molecules will have to occupy this, will occupy a smaller space. So what will happen? These molecules will start colliding with each other. They will get irritated. They will produce heat energy and raise the temperature of this parcel of air. And finally, when it reaches the ground, it will be at its maximum temperature because the molecules are now packed very close to each other, and this is the what is happening here. So this is the adiabatic warming. So one is air pressure, which is compressing or not allowing the air to rise, convection to take place and cause rainfall, to lower the temperatures. And when it is, the air is descending, it is getting adiabatically heated and further compounding the effect. So it is kind of a lid that has been placed over the surface. Moreover, whatever cloud formation is taking place, this compression, this high pressure is forcing the cloud to move away from the area. So whatever little chance of precipitation there was, that is also gone. that is also hindered. So this is warm air rising, then warm air. So this is the feedback loop which is getting created. So this is another factor. This is one of the most important factor that is leading to the heat waves. Okay, so you might have observed this melting roads. Okay, so now you must be wondering that roads are melting, only the maximum temperature might be around 40 to 45 degrees Celsius. So in India, the surface temperature, the temperatures, road temperatures, they can go as high to 60 to 70 degrees Celsius. Now, another difference is that, again, Europe is not accustomed to such high temperatures. So basically, the binding material, which is the bitumen, which is a petroleum based product, which is used as a binder to join the rocks and the aggregate materials to form roads, that is of lower grade as compared to those used in tropical areas such as India. So that this melts at a lower temperature. Moreover, you can see the tracks, the train tracks also, they buckle, they tend to buckle. Rutting is a phenomena. They buckle and they sink also. So this is, you might see, this is not AI or Photoshop. This is actually what is happening. Okay, now climate whiplash. Very important concept which needs to be discussed. So climate whiplash, like I've already explained briefly, it is the transition, it is a rapid transition between extremes of weather or climate. So you can see that high rainfall, then drought, and then heat waves, and then repeat. Okay, so that is what is happening. Now, I already told you that here, if you see, we have understood several factors causing heat waves or high temperatures in the Mediterranean region. But what about this? What about the areas, this Britain, even Scandinavia? This Sweden is also under the influence of heat waves. This France, these are supposed to receive precipitation throughout the year. What is happening is that wet conditions in these areas. What has happened is wet conditions took place, led to the growth of high vegetation. Okay. Then extremely dry conditions led to the drying up of the same vegetation. What is this doing? It is increasing the fuel. Remember fire triangle? Oxygen is already there. Okay. High temperatures are there in summer. And finally, we have got loads of fuel, which was the result of high precipitation during the earlier season. Okay, so high rainfall, it is an anomaly. You can say what an irony. It is a paradoxical thing that high rainfall is causing high vegetation, and that high vegetation is then responsible for high intensity and high frequency of wildfires. But this has become a reality, climate whiplash, the compounding effects, that not only the drought or wildfires are taking place at a high frequency, at a high intensity, but the rainfall, floods, these water related also are taking at a high intensity. Okay. So this I think is clear. Now, again, an important concept, Pyrocumulonimbus Clouds. Okay. Now this is interesting phenomena because till now we have been analyzing or studying the effects of weather, inclement weather or climate on wildfires. Okay. But what about what is happening now is that the wildfires or such unforeseen circumstances, such disasters, are creating their own weather. This is an example, Pyrocumulonimbus clouds. Normally, you might have heard of this cumulonimbus clouds. What are these? These are towering clouds which are associated with thunderstorms. The one we normally observe in India or in the northern plains in the months of May, June. Okay, so what happens there is for the formation of cumulonimbus clouds, high insolation throughout the day. The skies are dry, monsoon winds have not yet reached. Okay, in the plains, I'm talking about May, June. High insolation from the sun is causing the air to rise rapidly, then it condenses, it forms clouds, but that is not the end. When the droplets or the high water vapor, whatever water content is going down, the convection currents, also known as updrafts, are so strong that they carry these condensed water particles even higher. And this process repeats. That is why often the thunderstorms, what is thunderstorm exactly? It is a violent, short-lived violent weather condition, often associated with gust, squall, hailstorms, heavy rainfall, which we observe. So this scenario, this continuous updraft and strong downdrafts, these create huge towering clouds. These have an anvil shaped structure, and the cold air it descends, and the warm air it forms these clouds. So these are also called as supercells. And you might have observed that the rainfall is short lived in months of April, May, June in plains like Delhi. It is short lived with very high intensity. So that is the role of a cumulonimbus cloud. Now you attach pyro, Latin word which means fire. Now what is happening is here also, when a wildfire gets initiated and gets self-propagated, self-sustaining, then often what happens is this has become a uh, common phenomena of late. So these also form large clouds. The fire is burning, the ground is warming, convection currents, the clouds are forming. Okay, the clouds are forming. The only difference is that they cause negligible rainfall, and even if they cause some rainfall, it gets evaporated because of the high temperatures on the ground. So the rain, even when it could have extinguished the wildfires, that is unable to do its job. So again, so this pyro clouds, this consists of fire, this ash particles, soot, smoke, water droplets, lot of aerosols. So these are getting created. So these are similar to this, but the conditions or the prerequisites which are leading to this formation is very different from these. And these clouds, like these spread, the cumulonimbus clouds, they also spread for kilometers. So these also spread over a wide extent. And what is generally associated with cumulonimbus clouds is lightning. Why? Because in normal cumulonimbus clouds, we have the aerosol particles, the hygroscopic nuclei, some dust, water vapor. So ice crystals, they rub against each other. Friction. Here, fire, ash, smoke, dust, soot, water particles, they are creating lightning. And I told you in the beginning, one of the natural causes of wildfires is lightning. So then this lightning can hit several places on the earth. Rainfall is not taking place anyways. This lightning, it can trigger or initiate wildfires in far off areas. Again, compounding the effect, worsening the effect of wildfires. And moreover, now the feedback loop has even worsened. What we have studied till now is that hot weather, dry conditions, high temperatures, omega block, Mediterranean climate, lack of precipitation, high load of vegetation that are causing wildfires. Now, what will fires do? They will release more organic matter in the form of carbon dioxide, methane, nitrous oxides. What are these? Greenhouse gases. These will further warm the atmosphere. This will further enhance or worsen the weather conditions, make the atmosphere hotter, and then this goes on and goes on. So this is a vicious cycle which forms. Here, this is another example of the recent phenomena like pyrocumulonimbus clouds. You might have observed, heard of tornadoes. Not very common in India. In America, they are very common. So tornadoes are also, they are vortex or whirlpools whirlpool, column of whirlpools which join the supercells or cumulonimbus clouds to the ground. Similarly, what has been observed of late in some wildfires, this pyrocumulonimbus clouds, they produce this fire tornadoes or fire whirls. So this can also, you can you if you have seen in the movies, the tornadoes, they suck up debris and they carry away cows and homes. So this can also suck up the vegetation. This can carry, or this can uplift the vegetation and further spread the wildfire. Okay. Now, one important definition which I should have mentioned earlier is exactly the heat wave. You need to know this. What exactly is a heat wave? Okay, if I go now, heat wave is a prolonged or long period of sustained high temperatures in a particular region which are much above the average, long period average of those areas. For example, if a region in France or different nations or different areas had different criteria for proclaiming or declaring a heat wave. For example, in the northern plains in India, there are two methods, just telling you in brief. If the temperature in a particular region is above 40 degrees Celsius, and it is 4.5 to 6.4 degrees above normal for that particular period for 2 days at two meteorological stations, then a heat wave is declared. Or if we go by the exact temperature conditions, if the temperature in the plains is greater than 45 degrees Celsius, then a heat wave for 2 consecutive days, then it is immediately declared a heat wave. A small example. So for example, suppose in June, we have a temperature of 42 degrees Celsius. Okay. So this condition is satisfied for 2 days if we have 42 degrees Celsius. And for those 2 days, the normal temperature was 37 degrees Celsius, the long period average, the maximum temperature. So the difference, 5 degrees Celsius, it falls in this wave. So heat wave will be declared. So similar is the criteria for the Western nations also, European nations also. Now, one important difference that you should know is Lu and heat wave the same? No. Heat wave is a temporary condition which can last for some days or weeks. Lu is an example of a local wind which blows in the northern plains. So it is actually moving air. It is a warm wind. It is not necessary that Lu causes a heat wave or heat wave can cause a Lu, although one can supplement or complement the other. This is the thing. Okay, now we have discussed in the Mediterranean region lot of characteristics, its climate, climatic features, what makes it suitable for these wildfires, for these heat waves, high temperature. One important component. Now we have already discussed climate whiplash, ecological conditions. We are only talking about the environment, climate change, human role, but land use change. This is essential. Because again and again, we are saying that vegetation, we need fuel. Now, in a country like India, we often experience news such as deforestation of the Western Ghats, Aravallis. So actually, those areas in India are witnessing lack of vegetation. Okay. So, but in these regions, for example, Mediterranean region, what is happening is depopulation of the rural areas. The urbanization is taking place. So the people in areas such as Italy, Spain, France, they are leaving their rural areas or farms to go look for job opportunities in the cities. So what is happening is they are leaving farms, they are leaving animals, they are not collecting the firewood timber. So earlier what used to happen was grazing. What it does is it reduces the vegetation. Don't try to compare it with the Indian condition. It reduces the vegetation or the fuel load. Okay, it keeps the exponential growth or the unwanted growth of weeds, of bushes, of herbs, etc., of plants in check. So that earlier that used to remain check. Agriculture also, it used to keep the vegetation growth in check. Firewood, timber produce also, it used to keep the vegetation in check. But now, due to depopulation or the migration from rural areas to urban areas, it has led to the exponential growth of vegetation, which serves as sufficient fuel for creating wildfires in the dry period. One more important aspect, or one more important, wildfires are not always bad, inherently bad, because we always talk about the destructive nature or destructive images we see on the media or newspapers, or we discuss here in news. But actually, wildfires are also nature's mechanism of replenishing the nutrients, the soil nutrients, of restoring the balance in the ecosystem. There are actually some trees. You might have heard in the Himalayas, there is a tree, trees of cheer pine. So these have cones. These have cones, you might have observed. These cones have resins in them, resin, which is a highly inflammable material. So these actually, in order to propagate and reproduce, they need fire to open, for these cones to open and the seeds to get expelled and then reproduce. Okay, and these fires are also, when the ash, when the grass is burned, that ash is also rich in nutrients. It also replenishes the nutrients. It is, that is why the definition of wildfire is important: the uncontrolled and rapid spread. So normally you might have heard of this thing, fire breaks. So what happens is, for example, if there is continuous vegetation in a particular region, okay, and it is highly susceptible to wildfires. So what the firemen or the volunteers or the village people, they do is they remove the vegetation, they dig trenches in between where there is no vegetation at all. So if a fire is spreading in a particular direction, it will encounter a space which has no vegetation, and you remove any one element of the fire triangle: O2, water, temperature, or fuel, and you have extinguished the fire. So in this fire breaks, the fuel is getting removed. Otherwise, what we do is, if we use the fire retardants or the fire extinguishers, they cover the surface, they prevent the fuel from reacting with oxygen. So there the oxygen is cut. And if rainfall takes place, the common mechanism we use fire. So there the temperature, the ignition, the heat is eliminated. So this is important. Okay, so this land use patterns. One last thing, you might have encountered such type of map. So this is a map taken by the Copernicus system. It is the weather index. Fire weather index. It is an anomaly. It is not, it is what we have discussed in one or two previous lectures. It is an example of remote sensing. So it is not exactly showing the extent of the spread of wildfires. It is just saying that, boss, the dark gray areas, they represent the areas which are more susceptible or vulnerable to rapid spread of wildfire in case the fire triangle is satisfied. So it is just an anomaly. So initially, for example, you can see these light green areas here, low and moderate. So it is comparing the season yearly. So for example, last year in 2025, the area was susceptible to some degree for wildfires. So in today's year also, it is in 2026 also, if the fire index anomaly is close to zero, and that is why it is still prone to wildfire, but the danger is not as much. Here in the dark brown, red or orange areas, what it is trying to say is that if the fire triangle or suitable conditions are satisfied for the initiation and spread and propagation of wildfire, then it will spread much more rapidly as compared to the previous years. So you can see Mediterranean region, this is Portugal, then this is Spain, France, Germany, Italy. Okay, in between you can see this, because I know a little bit of geography, so you can see these areas. These basically are the Alps areas. So these have less vegetation, more snow, low temperature. So these are less and less susceptible. So here you can see these time the wildfires have not even spared the Scottish Highlands, which receive high precipitation and also observe normally low conditions. Then you can see this area. This is interesting to note that these areas we have studied continental experiences, but this area, this is Norway, this is Sweden. So country so close to the Arctic. We have discussed several factors. One additional factor which is interesting, which you can note, is the presence of the taiga climate. What happens is basically taiga stands for the boreal vegetation. So here the trees in this type of region, climate, spruce, fir, pine, these type of trees are common, which are not only homogeneous in nature. It is not a dense jungle. The same species are there in rows. And moreover, like I told you, pine, they need fire. They depend on fire to further propagate. So although it has very low temperature, but due to same types of trees and trees which are dependent on fire for their propagation, so these are also dry in this region, low rainfall. So all these, again, just remember the fire triangle and you can establish the reason why these regions are experiencing wildfires. And I had a lot more in mind to discuss the Indian perspective, how we are managing. But now the important thing is that scientists are not no longer saying how to prevent wildfires, how to mitigate wildfires, because already within 1 or 2 years we are going to breach the Paris target of not exceeding 2 degrees Celsius of temperature rise above the pre-industrial levels. So now the target is how to adapt and how to protect the people, how to prepare them for the wildfire season. So you see how horrific or how uh, this devastating the consequences, the causes and effects have become. So till then, I hope I have burdened you with a lot of concepts. So we'll keep the rest of the topics for the forthcoming lectures. So till then, just take a break, and till we meet again next time. Jai Hind.